Hi, everybody. My name is Bailey Nash. I'm a second-year PhD student in the department working with Yara Oxford. The project that I'm going to be working on uses stable isotopes in sedimentary cellulose to assess paleohydrological change and hydroclimate change in Greenlandic lake sediments. So first, a little bit of background about sedimentary cellulose isotopes. So cellulose is an extremely abundant biopolymer that gets preserved in sediments and is resistant to degradation on geologic timescales, making it a good compound to use for this type of epoxy work. Cellulose oxygen isotopes have been used extensively in lake sediment reconstructions over the past several decades. But as you can see, cellulose is comprised of carbon, hydrogen, and oxygen. So there's this potential to use multiple isotopes on a singular compound to get at better interpretations of these hydroclimate reconstructions. And so some recent work has shown that lake sediment cellulose also serves as an effective sensitive isotopic archive of major hydrologic events. So my plan is to use multiple isotopes of sedimentary cellulose preserved in these Greenlandic lake sediments to reconstruct specific aspects of the lake's hydrology through time and regional hydroclimate. So this summer, I was also part of the Greenland field team, and we actually targeted two different lakes, but my research is going to be focused on the second lake that we targeted. So we informally named this lake Mel 3. Mel 3 is on a high elevation plateau, a couple kilometers east of the town of Narsarsuaq, if you guys are familiar with Southwest Greenland geography, on this jut of land called Mellanlandet. And we targeted this lake because there was some evidence based off of Google Earth historical imagery and the underlying geology that this lake could be sensitive to the types of hydroclimate changes that we're interested in, making it a sensitive record for these types of reconstructions. While there, we collected, of course, lake sediment cores and lake surface sediments, but we also collected a bunch of plants and phytoplankton. So we collected aquatic and terrestrial plants. And the intention for my future work basically is to use all of those modern material that we collected this summer for a site-specific modern calibration study in which I'll measure multiple isotopes of all of these different potential cellulosic sources to the lake to get at the isotopic variability between these different sources. And then I'll actually develop the record of sedimentary cellulose isotopes from the sediment records and use that modern studies findings to better understand our downcore material. And I'm specifically interested on focusing warm periods throughout the Holocene, so the mid-Holocene thermal maximum from 8.2 to 4.2 thousand years ago, and the medieval climate anomaly in order to better understand how these Arctic lake environments respond to warmer climate conditions. And a broader impact of this work, I'm hoping, is to help prepare communities in Southwest Greenland who oftentimes get their municipal water from lakes for the potential of lake level fluctuation in the context of modern climate warming. So, okay, with that, I'll take questions. Cool. Yeah.
Wondering how well your methodology can resolve the idea of a climate being wet versus dry. What does that mean from your practice perspective?
Yeah, no, that's a really good question. So one thing that I'm really interested in doing that I think has not been really done in these types of paleohydroclimate reconstructions is taking the hydrogen and oxygen isotopes of a singular compound and calculating deuterium excess and comparing that to some of the ice core records in the surrounding region and their deuterium excess to try and get at like what did the balance between evaporation and precipitation look like throughout this time period, and like what can that tell us about in addition to what's already known and what hopefully I'll find out about broader regional hydroclimate signals to get at that specific question. So that's what I'm hoping this methodology will provide. And then the carbon isotopes, which we're not yet sure if we're going to actually pursue, but if we did, hopefully would provide more of like an environmental lens to help us better understand that those interpretations. So like how does vegetation influence this too? Because cellulose is of course produced by the plants and the algae. So cool. All right, I have to stop. Thanks.